So for the proper subset, did you guys get this one? That for it to be a proper subset, for the set B to be a proper subset of A, all elements of set B should be available here, and there is at least one element of this one of set A that is not available here. Gets?
Yes, sir.
Yes, sir.
And the other difference that you will see here is that a set is not a proper subset of itself, right? You don't see it here in the proper subset. So
Yes, sir.
that would just be available on the subset. Gets?
Yes, sir.
So for a superset, a set containing all of the elements of another set. So it is like the opposite of the proper subset, wherein the first set should include all elements of the second set. So this is the first element and this is the second element. So our example would still be this one, wherein A is a superset. And guys, remember the symbols, right? For the subset, proper subset, and superset. Guys,
Yes, sir.
okay. So for a superset, the symbol is this one, and says here that it contains all elements of the other set. So here in this example, A is the superset for set B, set C, set D, and set E. Gets? Because all of these elements is contained here. So set A contains all of these elements. Did you get it?
Yes, sir.
Yes, sir.
Okay, so let's talk about relation. Sino yung mga may relationship dito? By the way, guys, ano yung average age nyo for a first year college?
18, sir.
Okay, kasi 2 years kayo sa K11 tas K12. How about Mr. Fernando?
Yes, sir.
How old are you?
Too old. 33.
Okay, okay. So you're staying here in Baguio?
Yes, sir.
Is this your second degree or
No, sir.
it's your first?
Yes.
Okay, okay. So, okay, let's move on to the topic, relation. So let set A and B, wherein a relation R from A to B is a subset of, what is this again? Cartesian product, right? From
Yes, sir.
yesterday. Given an ordered pair, because it is a Cartesian product, it would give us an ordered pair. X is related to Y by R, written X R, or a relation, this symbol is relation, to Y if and only if the ordered pair X and Y is in R. So the set A is called the domain of R and set B is called its codomain. The notation for a relation R may be written symbolically as follows. X relation R to Y means that the ordered pair, this is the symbol for ordered pair, right? This ordered pair is an element of R. So the notation X is not R in Y means that X is not related to Y by R. And X is not R to Y means that the ordered pair X and Y is not an element of R. So let's just give an example for you to understand this. Our example here is a relation as a subset. So let set A 1 and 2 and set B 1, 2, and 3 and define a relation R from A to B as follows. Given any ordered pair XY, an element of the Cartesian product of set A to B. So for an ordered pair to be an element R, it means that X minus Y over 2 is an integer. So we have to meet this criteria here for it to be a relation. So you have to remember this criteria. Yes, X minus Y over 2 should be an integer for it to be an ordered pair as an element of R. So let's give an example. State explicitly which ordered pairs are in our Cartesian product of A and B and which are in relation. So this is the example. So from yesterday, the Cartesian product of A to B is this 1, 1. From here, guys, this is set A, set B. So 1, 1, 1, 2, 1, 3, then 2, 1, 2, 2, 2, 3. Gets this one for the Cartesian product?
Yes,
Yes,
sir.
So first, you have to do the Cartesian product of the two sets. And to determine explicitly the composition of R, or the relation, examine each ordered pair in A, ordered pair in the Cartesian product of A to B to see whether it's an element satisfying the defining condition for R. So our condition here is that R should be an integer, right? From this condition, X minus Y all over 2. So first is that we try this ordered pair. The first ordered pair here is 1 and 1. Is 1 and 1 an element of R? Because 1 minus 1 all over 2. You see here, guys, X minus Y over 2. Our first X here is this one. And our second X, and our Y here is this one, right? This one,
Yes,
X
sir.
and Y. So over 2. 0 over 2 is 0. Is it an integer?
Yes, sir.
Yes,
Yes, sir.
from our topic yesterday on the real number system, 0 is an integer. So it satisfies the condition. So this is a relation. Gets?
Yes,
Yes.
sir.
So for the other ordered pair, we test it. 1 and 2. 1 minus 2 all over 2 is negative 1/2 or negative 0.5. So it is not an integer. Gets?
Yes, sir.
So do you guys get what a relation is? For this topic, not our
Yes,
relationship
sir.
with our girlfriends or boyfriends. Yes. So should I move with the other topic, or we need to discuss this? Guys, so we test all the ordered pair that would be available in the Cartesian product. And then we test if it is an integer by the condition x minus y all over 2 if it's an integer. So for the other question, is 1 relation to 3? Is 1 relation to 3?
Yes, sir.
Yes, sir.
Yes, because for this one, 1 and 3, 1 again here from our definition, this one, xy, this is the domain, and this is the codomain. It could also be written as this one, right, guys? X is our domain. This is the relation, and this is the codomain. So in this question, this is the domain, or x. This is the codomain, or y. And in our ordered pair, 1, 3, this is this one. We test it that it is an integer. So for this question, is 1 relation to 3? The answer here is true. Gets?
Yes, sir.
Yes, sir.
So the first step that we have to do when we are dealing with relation is that we have to take the ordered pair for us to answer questions like this. Gets? So
Yes, sir.
is
Yes,
2
sir.
is 2 a relation of 3? Can you answer this? And this
No,
one?
sir.
Why not?
I mean, not really. 2 is not relation of 3.
Okay, okay. Let's check. 2 and 3. Okay. Nice. And how about the 2 and 2?
Yes,
Yes,
sir.
sir. It's related.
Zero,
Are
sir.
they related? Okay.
Yes, sir.
Yes. 2 and 2 is in relation with each other. So you guys get what a relation is?
Yes, sir.
Yes, sir.
Yes, sir.
So for the third question, what are the domain and codomain of R? So what's your answer? If you understand what are the domain and codomain of R? Anyone, guys? In our definition, the set A is called the domain of R, and set B is it's called codomain. So for this, what is our domain and codomain? Guys, anyone?
Sir.
What?
For the domain, it is 1 and 2, and for the codomain, it is 1, 2, and 3.
Yes, that's right. Because here in our definition, set A is called the domain and set B is called its codomain. It's not always the case, guys. Here, set A is the first element or first set that is in this Cartesian product, right? Set A and set B. So, our domain here is this set. So, if they change it to C and D, the domain is C and the codomain is D. Gets? It's not always the case, this case. It's just a representation. So whatever comes first is our domain, and the next set would be the codomain. Gets?
Yes,
Yes,
sir.
sir.
So, wag niyong isiping laging A at B lang yung set natin, guys, ha? It's just a representation, this set A and set B. Gets?
Yes, sir. Yes, sir.
Yes, sir.
So, this is the answer. The domain is the set that contains element 1 and 2. And the codomain is the set that contains 1, 2, and 3. Or this is set A and this is set B. So next is the circle relation. Oh, wait, guys. I'm just going to do something. So for the circle relation is defined as C from R to R as follows. For any ordered pair as an element of R, cross product with R. So here, the relation would be our cross product. And the ordered pair to be an element of C, it means that the x squared plus the y squared should be equal to 1. So for this kind of set, we have to test if the ordered pair will satisfy this condition. Gets?
Yes, sir.
So can you guys tell me if letter A is true or false?
True, sir.
How about letter B?
False, sir.
False. So about letter C?
Walang calculator, sir.
Gamit kayong calculator. About letter C?
Yes, sir.
Okay, how about letter D?
No, sir.
No, sir.
How about letter E?
True, sir.
What's the answer?
True.
Okay, how about letter F?
False, sir.
And then what are the domain and codomain of C, or the circle relation? What do you think is the domain and the codomain of this one? For circle relation, since we are testing the relation between the Cartesian product of R and R, so the domain here is the X and the codomain is the Y. So in these examples, the domain as it is written here, the domain here is this one, the codomain is this one. And for this type of question, the domain here is this one, and the codomain is this one. Gets?
Yes, sir.
For the relation itself, we are given two sets, right? The first set and the second set. So the first set is the domain and the second set is the codomain. So for this circular relation, we're not given the set, we're just given the ordered pair. So this is the X and this is the Y. So the domain here is this one and the codomain is this one. The domain here is this one, the codomain is this one. Gets?
Yes, sir.
Yes, sir.
Okay, so your answers here is right. But if you're given the elements of R for the circle relation, the domain would be the set of all the R. And the codomain would be the set of all the R also. Gets? Because if you're given an element of the R, since they are both here, so set of R is the domain and also the set of R is the codomain. Gets?
Yes, sir.
So for the arrow diagram of a relation, suppose R is a relation from a set A to a set B. The arrow diagram for R is obtained as follows. Represent the elements of A as point in one region and the elements of B as points in another region. For each X in A and Y in B, draw an arrow from X to Y if and only if X is related to Y by R. So symbolically, draw an arrow from X to Y if and only if X relation to Y, if and only if the ordered pair X and Y is an element of R. So an example for an arrow diagram is this one. Let set A be set with element 1, 2, 3, set B with element 1, 3, 5, and define relations S and T from A to B as follows. For all ordered pair to be an element of the Cartesian product of A to B, we should satisfy this condition. Ordered pair XY should be an element S, means that X is lesser than Y. S is less than the relation. So here we have this set A, which includes the 1, 2, and 3. And then for set B, we have this elements 1, 3, and 5. And the condition is X should be less than Y. So for us to draw the arrow diagram, we have to satisfy this condition, right? That is how our arrow diagram is. It should be an element of R, or it should satisfy our given condition. before we can draw an arrow from X to Y. So here, if this is our set A and set B, so our ordered pair here is this one, our X will be coming from here, right, guys? Because this is the domain. If we would write the ordered pairs of this Cartesian product, it would be 1, 1, 1, 3, right?
Yes, sir.
So our X would be set A, or our domain is set A. The elements would be coming from this set. So it is 1, 2, and 3. And our codomain is this, or the Y, is 1, 3, and 5. So we have to meet this condition. X should be less than Y. So 1 is lesser than 3. 1 is lesser than 5. 2 is lesser than 3. 2 is lesser than 5. 3 is lesser than 5. Gets, guys?
Yes, sir.
So we have to remember how to get the ordered pair from a Cartesian product. Remember, that's how we're going to solve this kind of problems. Gets?
Yes, sir.
So for this set T, we are given the ordered pair 2, 1 and 2, 5. So 2 will be our domain, or X, and 1 and 5 is our codomain. So in the given set, which is 1, 2, 3, we're just going to satisfy this condition. 2 and 1 and 2 and 5. Gets? Before we can draw the
Yes, sir.
arrow diagram. So, any questions here?
None, sir.
None? So, let's move on. Let's move to functions. Function f from a set A to a set B is a relation with the domain A and codomain B that satisfy the following two properties. For every element X in A, there is an element Y in B, such that the ordered pair is an element of F. For all elements X in A and Y and Z in B, if the ordered pair is an element of F and this ordered pair X and Z is an element of F, then Y is equals to Z. So for properties 1 and 2 can be stated less formally as follow. A relation f from set A to B is a function if and only if every element of A is the first element of an ordered pair of the function. So remember this, guys, that for the set A, all the elements should be the first element of the ordered pair. Gets? This A is only a representation of the first set, guys. Remember? So for every element of the first set, all the elements or the first element of the ordered pair of the F for it to be a function. And then no two distinct ordered pairs in F have the same first element. So we won't have the same X in the ordered pair for it to be considered a function. Gets?
Yes, sir.
Yes, sir.
Again, I will repeat. The first set, the first element, every element of the first set is the first element of the ordered pair. And no two distinct ordered pairs in F have the same first element. Walang mauulit na first element. At lahat ng first element should be located in the first set. So let's have an example. If A and B are sets and f is a function from A to B, then given any element x in A, the unique element in B that is related to x by f is denoted by f of x. So for our example, let set A be set with the element 2, 4, 6 and B with the element 1, 3, 5. Which of the relation R, S, and T defined below are functions from A to B? So this relation R 2, 5, 4, 1, 4, 3, 6, 5 is not a function. Why, guys? Why do you think that it is not a function? Guys, anyone?
Kasi sir, knowledge yung 4.
In English, because we have a classmate here from Germany.
Because 4 is repeated on another pair, sir.
Yes, that is right. But for it to be for you to understand it better, every element of the set A is the element of an ordered pair, right? For it to be a function. So 2, 4, 6 satisfy the condition, right? 2, 4, 6 is the first element of the ordered pair. But for our second condition, no two distinct ordered pairs in the function have the first element. So since 4 is repeated here, this is not a function. Gets?
Yes, sir.
So for the second one, for all ordered pair to be an element of the Cartesian product A and B, ordered pair xy to be an element of S means that y is equals to x plus 1. So we have to satisfy this condition. So first, we will get all the ordered pairs here. 2, 1, 2, 3, 2, 5, 4, 1, 4, 3, 4, 5, 6, 1, 6, 3, 6, 5. So this is the ordered pairs here. But here we have to meet this condition wherein x plus 1 should be true, right? So we test this one. The first x, 2. This is our x, right? From the ordered pair. Guys, this is x and this is y.
Yes, sir.
So we have to test the x. 2 plus 1 is 3. But the partner of that domain or x is 1. So 1 is not equal to 3. So this is wrong. So the only ordered pair that will satisfy this condition is the ordered pair 2, 3, and 4, 5. So we have to test this. 2 plus 1 is 3, and the partner of that x or 2 is 3. So 3 is equal to 3. Gets?
Yes, sir.
So for this other ordered pair, 4 and 5, so if x is 4, therefore it is 5. 5 is equals to 5. So in testing this, all ordered pairs should meet the condition for it to be a function. If one of the ordered pair doesn't meet the condition, so it would be considered as not a function. Gets?
Yes, sir.
Yes, sir.
So for the last one, T is defined by the arrow diagram below. This is our domain or the X. which is connected to 5, 4 is to 1, 6 is to 1. So all elements here is used, and there is no repeated element for this first X. Gets? Do you
Yes,
Yes, sir.
get the condition that every element of this set should be the first element, and this is the first element because this is the X. And then no two distinct ordered pairs have the same first element. So it is only the second or the codomain which is repeated. So if we will write this, it would be the ordered pair of 2, 5, 4, 1, and 6, 1. Gets, guys?
Yes, sir.
So that will be it, guys. It's the end of our class for today. So I will be uploading